Nowadays, of course, with new display technologies, we have capabilities well beyond anything the CRT could ever have thought of doing. So there's lots of triangles out there now. And some of these triangles are taking the F-65 as a camera, and that triangle shows the color gamut that the F-65 can capture. There's another one for an F-35. There's another one for print film. There's another one for DCI, digital cinema. That's the color space that is used in the digital cinema. And then the smallest triangle, of course, is our television system. And so there is a desire to have a bigger system. Now, if you think those weren't enough triangles, there are many more. I just want you to know that those aren't the only triangles that are out there. Now, today, when we produce content, we produce it in a color space that is called CapXYZ. You can see it in the green, and you can see that it is, the CapXYZ is very much larger than our color space. So why would anybody want to produce in a space that's very much larger than anything anybody can see? The reason for that is that CapXYZ is not a color space, it's a carrier. This is an important concept to the future of our television system. That, and I'm borrowing from Mike Heiss because I actually like his analogy. I used to use multiplying two 10-bit words, two words and having to have more digits if you start multiplying. But if you process, his analogy of this is if you have a full container of orange juice and you want to shake it up. Do you know how hard it is to shake up orange juice when the container is full? Do you know how easy it is to shake up orange juice when the container is only half full? In other words, if you want to mix something, if you leave room to mix it, it's easy to mix and you lose nothing. But if you have a container that's so tight and you want to mix something, it's actually difficult to mix it. So what we did in creating a standard for producing content, we now carry our content in a large container. So no matter what we want to do with it down along the line, there is space in that container to do it without losing anything. Does that make any sense to all of you? So we make the carrier very much larger than anything we want to display, and then that way we lose nothing in the process. So 5 years from now, if you want to go back and you want to do something with it, it's all there. So, and we don't have to worry about it. And among the wonderful things that they did in this system, the carrier is this big. And we actually send everything that's in that carrier to the motion picture theater. And at the motion picture theater, it has the capability, let's see, it's called P3, and it's this triangle right here, this purple triangle. So the carrier is this big, and the space, the color space that it's going to be displayed at is that really small triangle that's sort of in the middle someplace. So what we do is we put an output display transform. And this output display transform takes this big everything that's in the container and it conforms it to what the display is doing. That occurs at the theater. So that everything is sent to the theater, and then if it wants to run in that color space, there is an output display transform that will conform that information to look correct in that display. Now that carrier can actually handle multiple pieces of information. So if I want to take the information that's in the carrier and I want to make it 709, which is 709 is the orange one. I can find the orange one. If I want to make it, no, not that orange, that orange. Anyway, if I want to, sorry, but there's also another output display form that can take that same content and make it conform to a completely different color space. So there is metadata that says how you get from everything that's in the carrier to multiple color spaces. this has given a whole bunch of people a brand new idea of what UHD could be. UHD could actually be a carrier of information, a great big huge container, and we could actually deliver the contents of that great big huge container to you. And 20 years from now, when a manufacturer comes up with a new display, it's already there. Because everything that could possibly be created by our capture capability is in the carrier. And basically all you have to do is create an output display transform for whatever new system you come up with. So what this 2020 color space has introduced is a concept of now we can have multiple sets of rules. It's no longer a single set of rules for what television can be, but it can be a multiple set of rules. Now, why is this important? If we put UHD together properly, it can completely replace HD and give us our next 20 years of television. Whatever the manufacturers come up with, and you're going to find out when manufacturers get up here, you're going to find out today they're coming up with things that they hadn't thought about yesterday. Well, tomorrow they're going to come up with something new. And you're going to have a whole bunch of options in what you buy for a display. If I send everything to you in a carrier that has everything in it, and then give you an output display transform that will conform to whatever new device they can come up with, guess what? The content is right there. And also, guess what? Your existing TV sets, as long as they have an ability to identify themselves, can go back to the signal and say, I'm a 709 set, give me a 709 signal. Therefore, this UHD has a potential of delivering everything to everybody in a much higher quality than anything you've ever seen before. So all these triangles actually become important, and I'm showing you this large group of triangles because I want you to know that a number of people feel that, well, some people want to do this and some people want to do that. There's a way of accommodating every single one of them, which has never been done in our television system before. So this 2020 document opened up possibilities where people are beginning to see, oh, I can do a whole bunch of things. Oh, I'm sorry, microphone's not close enough. Sorry, thank you. All right, now, I want to explain a little bit about color and why this is important to me. This is what sunlight looks like. And I went out on an afternoon, I put an 18% gray card on the ground and photographed the sun with a spectroradiometer, and this is what it looks like. This is what sunlight looks like on some summer afternoon at my house in my backyard. So this is what lights up surfaces and allows you to identify colors. Now, this is what a CRT looks like. This happened to be a SMPTE CRT. And this is what the colors of red, green, and blue look like that had been used to color grade all of our picture content. Well, this was interesting until my projector came along. This is my projector. This is the red, green, and blue in my projector. Do you see that it is much closer to being inclusive of all colors everywhere? Now, just as soon as, now this still puts out the exact same colors of red, green, and blue, but the bandwidth is much larger. And among the things that was important in this, when my projector went into telecine facilities, the first thing they discovered is they could adjust for better color fidelity. They felt that they were getting better color out of the picture. The second thing that happened is there was much more consistency of agreement of what the colors look like. And it's something called menomerism, and it's our individual ability to see colors. Each one of us sees colors slightly different. If I'm covering a single color with a wide bandwidth, everybody's going to agree that color is the same. I'm going to show you what the 2020 looks like. Now 2020 is right out at the edge of the diagram, so there's single bandwidth. That's what This is an emulation because we still don't have 2020 displays. But if we get to 2020, this is what it's going to look like. And what happens here is we can combine red, green, and blue, and we can get to every other color. But the bandwidth of the colors are going to be so narrow that we will each disagree on what we're seeing. So there will be no consistency or no agreement on how we see colors if we actually go to 2020. So for all the manufacturers that are trying to get there, when they get there, and it's absolutely possible to do this, when they get there, they're going to discover it doesn't work. And
just quickly, do you happen to have a diagram like this of P3 color or no?
Not in this set of slides. I actually took it out for brevity. Yes, I actually have P3 in here. And I actually have LED backlit displays in here, which are all much larger in bandwidth than what you're seeing. So I apologize for that, but somebody told me that I had to keep this down to less than 2 days. And so I didn't include everything. Interestingly enough, there are surface colors out there that can't be conveyed in our current television system. And so there is a desire to have a greater color space, and it can be seen as more attractive than higher resolution. So in selling the concept of UHD, there is a belief that it's going to take much more than resolution to sell the concept. And among the things that I believe that will sell the concept of UHD is a total carrier that will contain lots of options so that we can experiment down the road and we can make TV sets that can do some phenomenal things that we hadn't thought of today, but the carrier will have all the information in it to make it do it. So at least the production people won't be caught anymore with, oh my gosh, we didn't think that was coming and we didn't think we had to do that. That if we come up with a system that carries everything that can be produced and then makes it conform, you'll get something. I'm guessing all of you know enough about neon colors to recognize that these aren't even close to the colors that you would actually be seeing if you were there. I tried to pick something everybody knows, Las Vegas. And there is absolutely room for an improvement in color capability that would be viable and interesting to the consumer. Now, getting there requires bit depth, and 10 and 12 bits aren't going to cut it. 12 bits is the beginning of what you need to carry just the extra color information. Now, if we've already said this, resolution alone is not enough. And what other options? Believe it or not, as much as we're talking about changing the primary colors, turns out that changing the color of gray will give us a better picture. Now, in the post-production world, we know this from digital cinema because we don't use D65 for the color of gray. We use a much lower color of gray. So among the things that could happen in this UHD system is we could have a whole new color of gray that would give us better color fidelity. Not only would we have a larger color space, but by putting the gray point closer to the center of the diagram, we could actually get better color fidelity. We could actually get better color fidelity out of 709, the existing high definition color space, if we would shift the grayscale. So among the options that could be contained in this carrier is another grayscale, functioning on a completely different grayscale. And then we talk about dynamic range. This is a big one in people believing that it will sell the ultra high definition format. The majority of high dynamic range illustrations that are being done today actually shift the gamma of the picture. So the majority of the picture is in the luminosity range that you see here, But what they do is they take specular highlights where the lights are hitting the vehicle in this case, and they pull those way up. So small areas of the picture are very bright, and incidentally, in doing that, in increasing dynamic range, among the things that you can do is you can actually get blue skies. Oftentimes you shoot pictures and the skies appear to be white. Does anybody ever notice that? Well, blue is the first color to go. If you had more dynamic range, the skies could be blue. Now, the problem with high dynamic range is light output. And light output is obtained by putting energy in. And there's something called, the star system, Energy Star, thank you. See how much I know. Energy Star, in other words, even in the state of California, there's limitations on how much how much current they can draw. And so there's going to be a limitation. In order to get high dynamic range, you do need a brighter set, but you also need the bit depth to drive it. So there are going to be real limitations on what high dynamic range is. Even with some of the latest backlight technologies that are being used with LCD, which are more efficient, there's still going to be limitations on what you can get out in light output. Now, when I photograph images, I'm shooting high dynamic range. So this is a picture that I took, and I did this on purpose. I took one look at this picture and recognized, oh, here's high dynamic range. Here's something I can illustrate high dynamic range. So what I'm doing, I can only display 8 bits at a time because that's what these sets are. They're 8 bits. So what I'm doing is I shot a 14-bit dynamic range. And what I'm going to do for you is I'm going to slide up and down on that dynamic range. And right now, I'm at the top end of that dynamic range. And you can see there's almost blue in the sky. And if I tweak the dynamic range a little bit further, I could actually show you that there is a blue sky up there. But for the most part, you can see that the details at the top end of the picture, the trees are all there. There's lots of detail. But in an 8-bit system, the bottom end of the picture is sort of not there. Well, if I decide that I'm going to slide down the scale now, and what's going to happen in an 8-bit system, do you see I've blown out the top end? But now I can see a little bit more of what's happening in the middle of the picture. And I'm going to do that one more time. I'm going to open up the bottom of the picture, and you can see that I'm blowing out the detail. Well, all that detail is there. In a high dynamic range system, every bit of that detail would come across. You would see the bright light, but the important thing, in order to get there, the light output of the display is going to have to be much brighter than the light output of any of the displays now. So to truly get to high dynamic range, you've got to have a light output capability, and you've got to have the bit depth to drive it. Otherwise, there's going to be serious contouring in pictures. Does everybody know what contouring is? It's when, along the edge of somebody's face, instead of a smooth transition from one level to another, you literally see steps. That's called contouring. And here's another example of dynamic range. When I shot this particular picture, the camera issues an 8-bit picture. It's called JPEG. It issues an 8-bit picture, but it also issues a 14-bit picture. That's what's in the 14-bit picture. That was what was in the 8-bit picture. So part of what I'm trying to tell you is that's what I shot. But when the camera picked 8 bits to output, that's what it put out. So it's important to have a dynamic range capability. The higher dynamic range is going to give us a lot more capability and is going to allow us to do many more things in the picture. But I'm just trying to illustrate that a lot of us, when we shoot, we capture much more dynamic range than can possibly be shown. And some of us would actually like to be able to show more of that dynamic range. And we honestly believe that it would be more attractive to you to see that dynamic range than it would be to see a higher resolution. As most of you aren't going to sit close enough to the set to see it anyway. Incidentally, when it comes to resolution, if you're truly going to see what's in a 1080p picture, you need at least a 6-foot wide screen. If you're going to truly see what's in a 2160p picture, you need a 12-foot wide screen, and if you're going to see what's in a 4320 picture, you need a 24-foot wide screen. So I've been telling everybody when we jump to 4320, the cost of 4320 is going to be the new house that you're going to have to build to put it in. And because if you actually want to see it, you're going to have to build a new house. And so I'm not confident of the return on investment of the 4320 format. It will come, but I'm not confident on the return on investment. All right. Now, issues of the display panels. We need 12 bits to produce a good signal. Now, the interesting thing is if we deliver 12 bits, we can actually produce a much better picture on an 8-bit display. So if I can get this carrier to you that has 12 bits or 16 bits, I can actually make a better picture on an 8-bit display. And I can have far less contouring. If I deliver more information, I can process it in a way that even on an 8-bit display, you won't see contouring. But if I only deliver 8 bits, I don't have that choice. So delivering a higher bit rate to your existing TV set is going to be important for picture quality. So if I can deliver that carrier that I'm talking about, then every TV set could look better than it does now. Now, the contouring often occurs in people's faces. People tell me you can't see it, but there's edges in here. You can see transitions in here where there's those. When I put this on a 10-bit display, those transitions are much smoother than what you're seeing here. And so if I could broadcast this, or if I could deliver this in a higher bit rate, I could have much smoother transitions than you're seeing here. Now, it turns out, I think everybody knows what gamma is. It turns out that we're going to be changing all that. And the sampling rate, it would be much better if we could deliver 444 than delivering 420. That could be another improvement. Every single one of your sets today can take a 444 input. That's a requirement of HDMI. So if I could deliver 444, you'd have a better picture. So, and we'll not talk about resolution, but the name of the game in Hollywood is more, better, faster frame rates, so more meaning higher resolution. Anyway, so what we want for UHD is we of course want it to include 1080p and 720p so that everybody gets to experience UHD, not just people who go out and buy brand new sets. And oh, by the way, there's a lot of controversy about if I buy a set today, is it going to be good tomorrow? If I send a carrier to you, the answer is absolutely. Not only is this set going to be good for you in the ultra high definition system, but the set any of the sets that you've bought in the past 4 or 5 years is going to be able to take advantage of the UHD system. So the answer is, yeah, buy now with confidence that it will give you something, it will show you some improvement, and of course the higher resolution sets will show you the higher resolution. And there are going to be changes, and anybody who's sitting here who doesn't believe that there's not going to be changes is absolutely crazy, because you've seen it happening, and you've seen it happening rapidly over the past few years, and it's not going to stop. Changes are going to come. Now, how do we accommodate those changes? The important part of the changes is the pipeline, getting the information to us. That is what almost everybody in the UHD system is missing. That they're all working on high dynamic range, and oh, by the way, they're going to produce it, and they can't actually get it to the set because the set won't take it as an input. There's nothing on the set that will allow them to input 12-bit 444 signals. And so what good is it if you can't input it to the set? What good is it to develop it? So connectivity is the most important part of UHD. And that is the first thing that we've got to work on, not the last thing. And if we can come up with a system of connectivity that can do everything, basically and the connectivity has everything to do with compression. And I put this up because HDMI 2.x isn't going to work. HDMI 2.0, whatever it was dead before it ever came out. Before product one ever came to the market, it was outdated. H.265 is completely outdated. It can't do the 12 bits and the 12 bits that are necessary. It can't do 12-bit 444. It's already dead. It isn't out yet, and it's dead. So everything that we're proposing now is tiny little increments of getting there. In other words, the increments that are being proposed for our next system of connectivity won't even do what we're proposing for the system. So in order for the system to grow and graduate, the reality is we've got to concentrate on connectivity. Everything from production all the way to the set, including production carrying enough information to the set so that the production provides you with multiple options in how it's going to be displayed, and those options can be continually updated. So as manufacturers come up with new ideas, the connectivity is already there, and chances are the information is already in the carrier. Because what's in the carrier is a limit of what we can capture. Therefore, we can't do any better than what we can capture. And so whatever innovations we come up with, as long as everything that we can capture is delivered, we have an ability to have an imagination for at least the next 20 years if we at least build connectivity that will allow us to do all of these things. So whenever you hear discussions of higher dynamic range, better color capability, and whatever, we'll never get it into the set if we don't have connectivity. And right now, we do not have connectivity. That needs to be the major focus of us going forward with UHD TV. So with that, I'll skip all the other things that have to go into that connectivity. But a large pipeline will allow everybody to innovate in whatever direction they want to go for time to come. There you go. Yes, can we switch over? I've actually been with Florian Friedrich on my own and with Florian Friedrich in Munich. I've actually been creating my own 2160p content. Now, we've been shooting at about 7.3K, so we're shooting at a much higher resolution. And so our carrier could actually accommodate, we're shooting everything 14 bits. Now, what you're going to see here has been reduced to 8 bits because we're still having trouble getting it into the sets. In other words, I'm filling that carrier, but I can't get it into the set. So, yeah. So we're only going to be able to show this on one display, I think. The camera, I'm sorry, the camera that was used to shoot the stuff you're going to see is the Nikon D800E. And it has one of the quietest pictures at the highest resolution of everything coming out. And another camera manufacturer, not to be named, saw my pictures at a SMPTE conference, and his comment is, "We'll get there." When he saw my pictures, immediately looked at my pictures and said, "We'll get there." But Nikon has since come out with a new camera that's quite a bit better. And it came out on the 27th of July, and I had it by the 1st of August. And I'm already starting to shoot with it because I want better. I want to fill that carrier with more stuff.
How are you going to convince companies like Verizon to pay the cost of storage and transmission of a carrier when most people are only looking at 10% That's
How am I justifying carrying so much information when we're seeing, yes, effectively we're throwing it away. I am convincing them based on the fact that most of the people who create content want a better future. And they don't want to be caught up by surprise of somebody coming up with a display and them not being capable of generating content to feed it. And most of the people that I'm talking to are quite willing to sacrifice and say, okay, for the time being, we're only going to use a small percentage of that carrier. But incidentally, I'm going to be using more than anything that's been done by anybody else. So what's going to happen, is that even the right computer?
Yeah, it is.
Oh, okay. Oh, so we lost.
Only because you want the showcase, right?
Yes, but can we drag it to the, just the, yeah. Florian's shot a lot of material on his own, and yeah, this is the material. This is stuff that I shot with my Nikon D800E. And it has spectacular detail capability with very low noise. And if you look, if you're at the right viewing distance, guess what? If you're at the right viewing distance, you can see a huge amount of detail and a huge, now we shot for dynamic range in here. If you can't guess, this was done on purpose because I wanted to show dynamic range. There's a huge dynamic range in these pictures. In other words, you see where the skies are white instead of blue? I have enough dynamic range in here so that if I had the capability of displaying, I could show you how blue those skies actually are. But I don't have the dynamic range here. Now, my master is actually 32-bit floating point. The pictures, here's a case where the carrier is much larger. I shot 14 bits. My carrier is 32. So I'm carrying 32 bits of information even though I only shot 14. So this is all produced in the 32-bit domain.
Joe, have you checked out Google Fiber?
Say again?
Check out Google Fiber?
I have not checked on Google Fiber. I don't know where those things are. Yeah, but the important thing, now you can only begin to see some of the fog that's in this picture, but if I had dynamic range, the fog, I could offer you everything that's in the lower part of the picture, but I could also offer you everything that's in here as well. And it's almost a crime to look at this at 8 bits. It was all shot for 14 bits. I mean, I'm trying to fill that carrier. And so I'm shooting everything to go in the carrier. And the few people that have seen it with more capability have understood that, oh my gosh, this is real. We can do it today. If Joe Kane can go out and shoot it, anybody can do it.
But Joe, where can you show this?
Well, on a digital cinema projector. Yes, because right now the DLP projector has a 16-bit capability. And I'm shooting 14 bits. Yes, I can show it to you. I can show you what this actually looks like. And there is a venue today where I can show you what I'm doing.
how much space does it take to store, say, a 2-hour movie in this with your carrier?
I don't have an answer for that. The 32-bit floating point system, when we've encoded it as 32-bit floating point with high dynamic range, everything included, color space, it varies. This picture content varies anywhere from about 10 megabits per second to 100 megabits per second, depending on what it is and how complicated it is. So that's the only answer. We're doing variable bit rate, but at 32 bits, I can get it. This content is anything from 10 to 100 megabits per second.
You need 100 in order to guarantee not.
Yeah, that's correct. I need 100 in order to guarantee that I get what I want to go across.
What kind of light output do you need behind that?
The kind of light output that we need for high dynamic range is in question right now. There are studies by certain companies that will tell you 20,000 nits. The consumers would like to see 20,000 nits. We're working with 100 as a reference today. So 20,000. I don't believe that. And I believe that you would have to go in with sunglasses, and why bother with that kind of light output if you have to attenuate it in order to see it?
Isn't Dolby talking about 1,000 as a minimum capability?
Yes, but I want to be careful not to name names. At this point in time, you can go out and get the publications are available, but I'd rather not. But there are people that are saying 22,000 might be where we eventually want to aim. And of course, it's maybe 220 volt outlets, you know, to be able to pull that off. Or maybe we're just going to have to start distributing 440 volts at 40 or 50 amps. You know, so the practical answer to your question is we don't know yet, because I don't believe the research has been done. People claim, there are papers out there that claim to have done the research, but I know from my own experience that I could never tolerate the kind of light levels that they say consumers are demanding. I mean, when my projector at home, I have a 7.5 foot wide screen, and when I put a new lamp in, a good new lamp in my projector, I can get 23 foot lamberts off the screen. I have to backlight the screen at that level. I cannot watch that in a darkened room. I have to backlight my screen. So I believe that, someday somebody will want a set that will compete with sunlight. They'll want to be able to put it out in their pool in the day, and they'll be want to be able to watch a movie. And it's not practical. So coming up with a practical specification is something I think we have to do. But we have to have the connectivity before we can get the signal into the set, before we can determine what's real. And that's something, several people have offered me an opportunity to do the experiments, and I said I have to have the connectivity first. That's it.
Questions from the web, actually. First is, can viewers download this content for themselves?
I'm sorry, I can't hear you.
Can the viewers download this content for themselves?
This particular content, not yet. Okay, here comes the plug for me. Sorry about this, and I didn't intend this. Yes, I did. I'm actually coming out with 2160p and 4K test signals with 32-bit capability. They'll be out hopefully by the end of this month. And so now, how do I go? I have to use a memory stick to get it to you because I don't have any other way of doing it. But all these 32-bit floating point things, I already have a full suite of test signals, and they're ready to go. And I'll also include 8-bit test signals for those who are stuck in that domain, like everybody. And we will follow through with my material, but I want to deliver my material first. So I want to deliver it as 32-bit. And so I've got to figure out how to do that before I can send it to you. But it is in the plans. We've mastered everything at 32-bit, and I want to deliver 32-bit. My first delivery, I want it to be 32 bits. And then I want to tell you what to do with it. You know, so it's going to be a little bit complicated, but somebody has probably known me to be on the bleeding edge. And so everybody else is saying, 12 bits? That's terrible. Oh, no, I want 32 bits. You know, I want to deliver 32 bits. Were there other questions?
You kind of answered it. The other one was you coming out from the test.
Yes, yes. It's in production.
Not a disc, but a thumb drive.
Yeah, it's going to be something else. It's not going to be a disc. Or if it's a disc, it's going to be a BDR, you know, a BD-R, where you put it in your computer and you load the contents out. But right now we've decided to distribute on a USB stick because most of these TV sets have USB stick input capability. And so what I'm doing is I'm thinking of every single format that these sets can handle, and all the test patterns are coming in all the formats. So I don't care what set I plug it into, I can get the test signals on the screen.
Are you going to call it Video Essentials?
UHD basically? The ultimate HD. But That's, it hasn't been finalized what we're going to call it, but the disc that's coming out is called DVE New Test Materials version 2. And a few of you have seen version 1, and so I'm coming out with version 2. So it'll be new test, the memory stick is going to be New Test Materials version 2. Anything else? Thank you.